Hi everyone. Hi everyone. This is Asma Mushtaq from the W Vibes, and in this video lecture, I will explain how the Cramer's rule can be applied for a 3 by 3 matrix, which means here we will have the system of equations of order 3. Fine. So let's assume that we have the equations 2x plus y minus 5z is equal to 6, and then x plus y plus z is equal to 5, while x minus y plus 2z is equal to 4. Alright, first step is to write this in the form of the matrix, like in the system of the linear equations, that is ax is equal to b. So a is actually the coefficient matrix, which is 2, 1, minus 5. This is from the first equation that I have obtained, and here we will keep multiplying with the variables x, y, and z. And the first equation is actually equal to the constant 6. Okay. The second coefficient is 1, 1, and then 1. And the last row will be 1, minus 1, and then 2. Alright. The first step for finding or applying the Cramer's rule is to find the determinant of A. The determinant of A can be found quickly by writing this matrix inside the straight bars, just to indicate that this is the determinant, and we will expand it to the first row. In order to see how to find the determinant of a matrix, you can watch from the link that I will mention in the description. So hence you can see we have found the determinant of the matrix like that. Now the next step is to find the values of x, y, and z. I will represent x is equal to dx divided by the determinant of A. And what is dx? The dx is actually another determinant that we will find. And here in place of the x, like for this whole scenario, what I have write, I will have to write the value of the column vector b, which was equal to 6, 5, and 4 in this case. So 6, 5, and 4 in this case. Fine. Let's just go and write it over here for finding the value of x, 6, 5, and 4. While the rest of the entries will remain same. They will not change. So here I will write 1, 1, and minus 1, minus 5, 1, and then 2. Now let's just simplify it. I'll simplify it from the first row. So I will have 6. Then inside the bracket 2 into 1 is actually 2. Then minus minus plus 1. Then minus 1. Then I will have 5 into 2s are 10. And minus 4. The last entry will be 5. So you will have minus 5 and then minus 4. Okay. So it becomes 3 minus 1. 10 minus 4 is actually 6. Then minus 5, and here you will have minus 9. 18 minus 6 plus 45. Let's just simplify it and you will get it's equal to 57. Fine. And the x can be found by dividing this 57 with the determinant of A, which was equal to 15. So this is the value of x. Similarly, we will follow the same steps for finding the value of y. So for finding the value of y, now what we will do, we will represent, this is actually dy will be divided by the determinant of A again, and dy is actually written, since y is the second variable, so the first entry of the matrix A will remain as it is, which is 2 1 1, and similarly the last entry, which is minus 5 1 2. So 2 1 1 minus 5 1 and 2. While in place of this, I will write now the value of b, which is 6 5 and 4. And again we will expand this determinant. Let's say it's equal to 2, then 5 2s are 10 minus 4. Then the second entry, we will mention it by minus 6. So this is minus 6. 2 into 1 is 2 minus 1. And then finally minus 5. And for the minus 5, you will have 4 minus 5. On simplification, you will get the answer is equal to 11. So y will be equal to 11 divided by 15, which was the determinant of A. Okay, the last step is to find the value of Z. And for finding the value of Z, we will write it like Z is equal to dz divided by the determinant of A. And now what we will do, we will keep the first row as it is, which is 2 1 1. Then we'll keep the second row or column of the matrix as it is, which is 1 1 minus 1. So 1 1 minus 1. And what we will do, in place of the third column, we will replace the value or put the value of b, which is 6 5 and 4 in this case. The next step is to simplify it or expand it using the definition of the determinant. Hence you will see that dz is equal to 7 and z will be equal to 7 divided by 15. Now let's verify the solution values that we have determined. So x was equal to, it was over here, x was equal to 57 over 15. Let me write it down. X was equal to 57 over 15, while y was equal to 11 over 15, and z is equal to 7 over 15. We will put these values in any of the equations of the system. So let's verify it. X plus y plus z should be equal to 5. Okay, so the x is equal to 57 over 15 plus 11 over 15, then plus 7 over 15. We will just take the LCM, so 57 plus 11 plus 7. So this is equal to, it's equal to 75 over 15, and you know that 75 divided by 15 is equal to 5. So the left hand side is equal to right hand side. So this is our solution. X, y, and z will be written in the vector format, where the value of x is equal to 57 divided by 15, value of y is equal to 11 divided by 15, and the value of z is 7 divided by 15. So this is the solution, and thank you for watching.